In this video, we're going to talk about floor and ceiling functions. All real numbers can be thought of as being made up of two parts. An integer part, which we'll call k, and a decimal part, which we'll call d. K plus d, that is, our integer part plus our decimal part, can be said to equal x, where x is a real number. Let's consider a number line, and let's take, for example, the number 7.2. Here, our integer part, k, equals 7, and our decimal part, d, equals 0.2. If you were asked to find the floor of 7.2, then you would be looking for the nearest integer that was less than or equal to 7.2. In other words, the floor of 7.2 would be the integer 7. If you were asked to find the ceiling of 7.2, then your job would be to find the nearest integer that is greater than or equal to 7.2. In this case, the ceiling of 7.2 would be 8. Notice that the rules of rounding numbers do not apply here. For example, if I asked you to find the ceiling of 8.1, the answer is 9. If I asked you to find the ceiling of 8.8, the answer would also be 9. This is because we don't want to really think of it as rounding numbers. Rather, we're looking at the floor and ceiling function as a way to find the nearest integer, either less than or equal to a real number in the case of a floor function, or greater than or equal to a real number for the ceiling function. Let's look at another example, and again we'll use a number line. Suppose you were asked to find the floor of negative 3.3. The floor of a real number is the nearest integer that is less than or equal to a real number x. Therefore, the floor of negative 3.3 would be negative 4, because negative 4 is the nearest integer that is less than or equal to negative 3.3. The ceiling of x, where x is a real number, is the nearest integer that is greater than or equal to a real number x. Therefore, the ceiling of negative 3.3 would be 3. Since 3 is the nearest integer, negative 3. Since negative 3 is the nearest integer that is greater than or equal to negative 3.3. Let's take a look at a few more examples. The floor of the square root of 3 is equal to 1. The ceiling of 0 is equal to 0. The floor of 0 is also equal to 0. Since the ceiling of an integer is simply the value of the integer, and the same for the floor. The floor of an integer is the value of the integer. Suppose we look at the number 8.39. If we wanted to separate the integer and fractional parts, our integer part, k, would be equal to 8, and our fractional part, d, would be equal to 0.39. As you can see, finding the floor or ceiling of a real number is pretty straightforward, as is separating a real number into its integer and decimal parts. This concludes our example. I hope you found it helpful, and we'll see you next time.